well, and I think that we had a pretty frank discussion with, so frank that you almost sensed that he was headed for the door. Got a temporary fix. Long-term solution. I do. Green jacket back there?
Right, I just
Yeah.
want to make sure.
Are together here.
So we're really going to suggest a Jupiter sample return rather than Mars. I think that's what I was just telling Steve that.
Thank you for being here, sir. This hearing will come to order. Good afternoon. I want to welcome all of our witnesses to today's hearing. Today's hearing continues the committee's review of NASA's fiscal year 2009 budget request, and this time we're going to focus on NASA's space and Earth science program. NASA's science program has long been one of the agency's crown jewels, and it has delivered outstanding results since the dawn of the space age 50 years ago. Results that have rewritten the scientific textbooks and captivated the imagination of the public both here and around the world. I want to see that record of accomplishment and inspiration continue. However, I'm concerned that NASA's science program is facing an uncertain future under the funding plan offered by the administration. I know that Dr. Stern is going to put the best face on the outlook for NASA science in his remarks today, and he will point to a number of areas such as funding for research and analysis and suborbital research where NASA has taken steps to improve what was a bad situation. And he will undoubtedly point to NASA's plans to initiate a number of exciting new science missions, including JDEM, an outer planets mission, a solar probe, two of the Earth science missions recommended by the National Academy's Decadal Survey, and a Mars sample return mission. I want to commend Dr. Stern for his efforts to address some of the stresses facing the science community from past NASA budgetary challenges and for the energy and commitment he has brought to his job. Yet, as we will hear from a number of our witnesses today, it is not at all clear that it is going to be possible to sustain those new initiatives in an effective manner under the administration's assumed funding plan. For example, the National Academies estimated that some $7 billion would be required over the next 12 years to carry out the 15 NASA Earth science missions recommended in the Decadal Survey. However, the administration's budget plan for the next 5 years would allocate less than $1 billion to that effort. In the area of Mars exploration, the budget plan would cut the annual funding for the Mars program in half over the next 5 years, while still planning for the launch of an ambitious Mars sample return mission by 2018. And even though the cost of a Mars sample return mission has been estimated to be in the $5 billion or higher cost range, NASA is planning to spend only $68 million on technology risk reduction activities for the mission over the next 5 years, an amount that seems quite low for a mission of such complexity and difficulty. Congress will better need to understand NASA's plans and assumptions, as well as the impact on the current integrated Mars exploration program, before we can feel comfortable in moving forward. Another area of concern is the outlook for NASA's astrophysics theme. Not only is NASA estimating a cost for its new JDEM initiative that is lower than the cost estimate contained in the recent National Academy's Beyond Einstein report, but in addition, essentially all of NASA's 5-year funding wedge for future astrophysics missions is already assumed to be needed to compensate for low levels of reserves in the James Webb Space Telescope project. I could go on, but the basic situation is clear. NASA's challenging new science initiatives are to be built on a budget that increases by only 1% through fiscal year 2011, and that assumes only inflationary increases at best in the years beyond that. There will be little new money. Instead, there will be a continuing need to transfer funds across the science accounts to support each new initiative, an approach some might call robbing Peter to pay Paul. I'm very concerned that such an approach will not prove sustainable or credible, and assurances that improved cost controls will allow all the projects to be effectively carried out will need to be validated, given that 8 NASA science projects have already exceeded statutory cost and schedule growth thresholds. We've got a great deal to discuss today. I again want to thank all of our witnesses for participating in today's hearing, and I very much look forward to your testimony. The chair would now like to recognize the gentleman from Florida, Mr. Feeney, the ranking member, for an opening statement.
Well, thank you, Mr. Chairman, and thank you for your opening statement. I appreciate all of our witnesses for taking time from their busy schedules to be with us today, and we greatly value your input and perspectives as we approach a new budgetary year. Today's hearings examine NASA's fiscal year 2009 science and budget, the changes proposed by this budget relative to fiscal year 2008, and their rationale. I commend Dr. Stern, we're glad to see you here today, and his management team for putting together an exciting and responsive fiscal year 09 budget request. Bearing in mind that the NASA science budget profile is essentially flat, the FY09 request nevertheless makes a good effort at remedying a number of deficiencies that have been highlighted in recent years. Through this request, Dr. Stern has demonstrated that he's listening to the research community by, among other things, adding resources to the research and analysis program, increasing the number and frequency of small missions and suborbital flights, and initiating missions proposed in the Earth Sciences Decadal Survey. This budget request also proposes to add a flagship mission to the outer planets, initiate an exciting mission to explore the questions of dark energy, and rigorously control mission costs to ensure that the taxpayers receive maximum benefit. I fully support all of these measures. Particularly want to ensure that the continuity of missions and prevention of data gaps is preserved. Also, flagship missions should not be allowed to crowd out smaller but still significantly scientifically important missions. A robust science portfolio should contain a variety of mission types and objectives. Having said that, I want to re-emphasize concerns that I raised last month at our hearing on NASA's fiscal year 09 budget. America is the world's premier spacefaring nation. Space preeminence results from the interrelationship amongst military, civil, and commercial space endeavors. Each augments the others. Leadership must be maintained in each activity. Strength in only one does not create space preeminence. This approach also applies to the separate NASA directorates. Each augments one another. Each must pursue and achieve excellence to ensure NASA remains the world's preeminent civil space agency. But as time passes, that terrible February day when we lost Columbia, we run the risk of reverting to pre-Columbia behavior. As the Columbia Accident Investigation Board observed, NASA has usually failed to receive budgetary support consistent with its ambitions. The result is an organization straining to do too much with too little. Both the legislative and executive branches, as well as various NASA constituencies, are susceptible of lapsing into this behavior. We are often eager to assign new missions to NASA. This complement stems from NASA's ability to perform the most difficult and extraordinary of assignments. But all of us, and I emphasize the use of the plural, shun from providing that which is necessary to continually achieve this excellence. The result of our actions is that NASA's resources are shrinking in real terms while the agency is charged with maintaining America's preeminence as a spacefaring nation. The Columbia Accident Investigation Board observed continued U.S. leadership in space is an important national objective. That leadership depends on a willingness to pay the costs of achieving it. I don't mean to divert this hearing's focus, but I want to emphasize that all of NASA's programs are interdependent. When extraordinary or unforeseen problems are encountered in one, it's not uncommon to see the effects ripple throughout NASA's other programs. Turning back to NASA science, I remain awed by the breadth of missions that have been flown or are now flying, the discoveries they have enabled, and the cadre of exceptionally talented and motivated scientists and engineers who are the heart and soul of this enterprise. Their collective efforts have generated worldwide renown for NASA as an agency having no equal. And having invested billions of dollars over the past 50 years to develop and nurture this extraordinary capability, it is imperative that we sustain it. As we begin the next 50 years of science and exploration, I want to ensure that NASA's science programs are not burdened by mistakes of the past. We must ensure more stability in policies, resources, and agency management. We must use accurate cost estimates. We must implement management controls to lessen the likelihood of skyrocketing growth in mission costs. Later this spring, this subcommittee will begin drafting legislation reauthorizing NASA. I know our witnesses will provide us today with well-reasoned guidance and suggestions on how to provide policies and resources needed to sustain and build on NASA's record of achievements. With that, again, I want to thank you, Mr. Chairman, and our witnesses, and I would yield back the balance of my time.
Thank you, Mr. Feeney. If there are members who wish to submit additional opening statements, your statements will be added to the record without objection, so ordered. And in addition, I would like to include a statement for the record from the Planetary Society into today's hearing. Moving on, at this time I'd like to introduce our panel of witnesses, and I might like to add we were conferring briefly during Mr. Feeney's statement. It looks like there will be 2 votes on the floor of the House in the next 10 minutes or so, and what I'd like to do is continue the hearing as long as we possibly can, then we'll recess temporarily to travel to the floor and cast those votes. But let me introduce this remarkable, impressive panel of witnesses we have today. First up, we have Dr. Alan Stern, NASA's Associate Administrator for the Science Mission Directorate. Next to him, Dr. Lennard Fisk, who is the Thomas M. Donahue Distinguished Professor of Space Science at the University of Michigan, as well as the Chair of the National Research Council's Space Studies Board. Dr. Berrien Moore is at the center of the table, is the new Executive Director of the Climate Central, as well as the Chair of the National Research Council's Committee on Earth Studies. Next to him, Dr. Stephen Squyres is the Goldwin Smith Professor of Astronomy at Cornell University, as well as the Principal Investigator for the highly successful Mars Exploration Rover Project. And finally, it's a pleasure to introduce a constituent of mine from my home district of Boulder, Dr. Jack Burns, who is a professor of astrophysics and space astronomy, as well as the Vice President Emeritus for Academic Affairs and Research at the University of Colorado at Boulder. Welcome. As our witnesses should know, spoken testimony is limited to 5 minutes each, after which the members of the subcommittee will have 5 minutes each to ask questions. I'm going to return to Dr. Stern, and I should, so the record is clear, also acknowledge that Dr. Stern is a constituent of mine as well, as a longtime resident of Colorado, and has taken on a very important assignment at NASA, and we're very proud of the work you've done, Dr. Stern. The floor is yours.
Thank you, Mr. Chairman. Chairman Udall, Ranking Member Feeney, members of the committee, thank you for inviting me here to discuss NASA's FY09 budget request for the Science Mission Directorate. It's been my pleasure to serve for almost a year now here at NASA, and I want to acknowledge the strong support of both Administrator Griffin and the exemplary leadership team that we have at SMD. These are exciting times in space and earth sciences. We're currently building or flying 85 separate flight missions, and we fund over 3,000 research grants to scientific investigators. In the past year alone, NASA satellites have observed new details of subtle interaction between the oceans, the atmosphere, and polar ice that portend global change. Messenger just gave humanity its first look at the unseen side of Mercury. Cassini continues to reveal new insights about Saturn, its rings and moons. The Stereo mission is providing revolutionary 3D images of the Sun. And our space telescopes, Hubble, Chandra, and Spitzer, are giving us tantalizing clues to the nature of dark matter, dark energy, and they're revealing characteristics of planetary systems around other stars. These are just a few examples of the exciting developments going on in our field. However, as we look ahead, as you know, we are confronted with a series of challenges. When I arrived last April, I said that we would address the concern that SMD's portfolio had become too heavily weighted towards large missions at the expense of small and medium-scale opportunities. One of the most harmful consequences of this imbalance was the steep reduction in the number of opportunities for flight research, particularly in the 2010 to 2012 timeframe. In addition, I said that I would redress the decline in funding for research and analysis and the reduced science return on large investments that we're making in the science missions that we're flying. Well, in the FY09 budget request, we made budget priorities of these very important needs. We also adopted 2 additional budget priorities: accelerating progress on the Earth Science Decadal Survey and building a lunar science community. With Administrator Griffin's backing, the President's budget request accomplishes all of these objectives. More specifically, the new budget request offers 7 new funded starts, significantly increases R&A, steeply accelerates the suborbital program, initiates a lunar program, and makes a head-turning start on the Earth Science Decadal Survey. As described in NASA's budget justification, the proposed program is fully supported with this request. To ensure that, we will continue to closely manage the cost and schedule through the development cycle. We'll identify descoping options and appropriate trigger points. We'll consider rescoping missions when cost boundaries are violated. We're also placing a new emphasis on the value of experienced principal investigators, on ensuring adequate mission reserve funds, and on stronger international collaboration ties. Regarding our plans for mission new starts, it's important to note that we launched 4 missions last year, and we plan on launching 6 missions this year. As you know, when a mission is launched, its budget profile steeply declines from the development phase to the operations phase. Those 10 missions that we have launched represent 10 new wedges that have opened up, and those are the wedges that are supporting, in large measure, the new starts financially that we are making in space and earth sciences. Now, I do want to point out that the nature of program management with any fixed budget means that resources are limited and choices have to be made. That's not a bad thing. In fact, it enforces a clarity of purpose and prioritization that both NASA and the scientific community have embraced. But I do want to specifically highlight the fact that none of our 4 science areas, with the budgets that we are proposing, can achieve a balanced program while sustaining 2 simultaneous flagship class missions. Therefore, it's inevitable that the astrophysics budget cannot bear a second flagship while developing JWST, and that the planetary program cannot bear both the Outer Planets flagship and the Mars sample return. So we must do them in sequence, in series, rather than in parallel. I believe we've been successful to date in this kind of regard, and I want to offer two examples of that success. The first is that in astrophysics, we have scoped appropriate cosmology and exoplanet missions that are medium scale that can coexist with the development of JWST so that we can make progress before the development of JST is complete in both dark energy and later in exoplanets. The second example is in rectifying the D grade that the National Research Council gave us in terms of outer planet exploration. We intend to fix that, and we're doing that because the Mars program has enjoyed a recent high, a 25-year high in its budget. It's almost unprecedented. That high is due to the fact that we've been developing a Mars flagship called MSL, the Mars Science Lab. As that development finishes, the Mars program will be returning to its historic average over the last 25 years to make room for the Outer Planets flagship. Then, following the development of the Outer Planets flagship, we'll have an opportunity to ramp the Mars budget back up to do Mars sample return. And we take turns, as we have in the past, with Cassini, then Mars Science Lab, next Outer Planets flagship, and then Mars sample return. In closing, I hope that the other witnesses here today share the view that the Earth and Space Science Program of the United States is the most ambitious and successful such program in the world. In fact, our efforts are the envy of the world. They're something every American can be proud of. Thank you for the opportunity to share our plans and perspectives with you and for your support of our efforts to chart a bright future for the space and earth sciences.
Thank you very much, Dr. Stern. Dr. Fisk?
Mr. Chairman,
Mr. Fisk, is your microphone on?
Sorry?
Excuse me.
Good. Push to talk. I can follow instructions. You asked a series of questions of me in your invitation, and so let me just simply address the questions that you asked. You asked whether the space science program is moving in the right direction. There are, as has been noted, many positive features in the proposed FY09 budget for the Science Mission Directorate. There's 7 new starts. There's an increase in the research and analysis budget. The space science community is buoyed by the opportunities to pursue new science missions, and it is relieved that the unwise decisions of the past with regard to RNA have been reversed. All of these positive features have been achieved, however, within a fixed budget of only 1% annual growth, and this is a problem. Some of the new starts come at the expense of other programs that are displaced or deferred. The growth in earth science is clearly heartening given the importance of the program, but it came at the expense of other divisions. And so in many ways, SMD is a graphic illustration of the dilemmas that face all of NASA. Too few resources to accomplish the many tasks that the nation has faced before the agency. Whether it's exploration, the use of the space station, aeronautics, or science, the funding is not adequate to do all the things that SMD should be doing. SMD is doing extremely well with what it has, trying to maintain the vitality of the space and earth science program, but there is so much more that we could be doing. You asked in particular about heliophysics. There's good news here also. There's a new start for the Solar Probe mission, which together with the European Space Agency's Solar Orbiter mission, for which NASA has agreed to provide part of the payload, presents a historic opportunity to develop a comprehensive and predictive understanding of the basic processes that control the solar atmosphere and its influence in particular on Earth. You asked me about the status and health of the science and engineering workforce. The civil service workforce at NASA has a disturbing age distribution. It is strongly peaked at age 45 to 49, with only a small fraction that are under 30 and almost an equally small fraction that are over 60. It needs to be rejuvenated, but that, of course, is a difficult task with the constraints that exist on NASA. With regard to the space and engineering workforce outside of NASA, there are students available to participate in the space program. Here the issue is the quality of the students. Why should the best and the brightest choose careers in space given that we have not made space a national priority? There's a need for hands-on training of these students, which has the corollary benefit that providing such training to undergraduates invariably recruits them into careers in space. You asked about the status of the NASA Space Weather Program. Here there's a need to be sure that there's an adequate monitor of space weather events at the L1 point, which is in front of the Earth, but that may well be a NOAA responsibility. We also need to recognize that a true capability to predict space weather will only come when we have developed adequate understanding of the governing physical processes, and that in turn requires a comprehensive heliophysics research program at NASA. Finally, I'd like to comment on the issues that need to be addressed in the reauthorization of NASA, which I understand you are considering. We are 4 years into the vision for space exploration announced by President Bush in 2004. So far, the money that was promised to execute the vision has not been provided, and it is hard to say that the vision has generated much excitement, particularly among the young, who are expected to benefit most from the future the vision promises. I encourage you to ask whether there was a flaw in the vision which we did not realize at the time. The vision is about the future, extending our civilization into space, but there is a little of immediate concern to the taxpayers. And so I encourage you, as I would encourage the next administration, to provide NASA with a role that is not only about the future, but it is also important in the present. It could be a geopolitical role that improves our national image. It could be a role that improves our competitive position. It could be a re-emphasis on those programs in NASA that are of demonstrable interest to the taxpayer, like earth science or like aeronautics. Thank you very much.
Thank you very much, Dr. Fisk. Dr. Moore?
Chairman. Mr. Chairman, Ranking Minority Member, and members of the committee, thank you for inviting me to testify today. Mr. Chairman, as you and your colleagues know well, the world faces significant and profound environmental challenges. Shortages of clean and accessible fresh water, degradation of terrestrial and aquatic ecosystems, increases in soil erosion, changes in the chemistry of the atmosphere, declines in fisheries, and above all, rapid pace of substantial changes in climate. Information from NASA and NOAA's environmental satellites is critical to addressing these problems. But as a result of significant cuts over several past budget cycles, the growth in the cost of accessing space and in the development of instruments, and inflation generally, we find ourselves with a growing mismatch between needs and resources. The fiscal year 2009 budget for NASA begins to readdress some of this imbalance, but much more will need to be done for many budget cycles to come. Let me now turn to some of the questions that you ask. Is NASA headed in the right direction? And what changes or challenges or changes would I recommend? The President's fiscal year 2009 budget for NASA includes a major new initiative in earth science and applications, including a plan to provide $910 million over 5 years that addresses to varying degrees the decadal survey's nearest term recommendations. In addition, the budget provides for the restoration for the ozone limb sensor to the NPOS preparatory program, to integrate the Earth Radiation Instrument Series back onto NPP, and to support identification of a possible flight for the total solar irradiance sensor. All of this is very welcome news, but I have several concerns. The initiative's funding for earth science comes, as Dr. Fisk noted, at the expense of other NASA science programs. Approximately two-thirds of the additional $910 million for earth science are obtained by drawing resources away from the other science areas in the Science Mission Directorate. As I will note in my next point, earth science requires an ongoing commitment of funding at a higher level than is provided in the FY09 budget runout, and a simple redistribution of resources will not be a long-term solution. As has been noted by members of this committee, NASA is being asked to accomplish too much with too little. What is needed is an increase in the overall top-line budget for NASA, which in turn will allow an increase in NASA's science budget. Let me illustrate the point. This I provide in my testimony, and it's simply an update of what was in the decadal survey, where we looked at the past 10 years in constant FY06 dollars. We've now updated this graphic, looking at the past to now include the future, and that is to look at the proposed budget in FY08 as well as the FY09 and the 5-year runout. In FY06 constant dollars, the runout slope turns negative after 2 years. This simply says that we really are not yet on a path to addressing the recommendations in the decadal survey. I am encouraged, of course, and I must be encouraged about the renewed emphasis on earth science. However, without additional resources, there's a limit to what management's best intentions can accomplish. The The NASA Earth Science Program is doing what it can with the resources it has been given. It is not being given enough to accomplish what is expected of it, and more importantly, all that the nation needs. What further challenges do I foresee for NASA in the earth science, and what would I recommend to address those challenges? If you look at the proposed response to the decadal survey, you see that 3 missions, other than the venture class, 3 missions are being recommended. From the first set of 4 missions that we recommended, 1 to fly in 2012, dealing with soil moisture, 1 to fly in 2015, dealing with sea ice, and 1 to fly in 2017. So by 2017, we will have flown off 3 of the 17 recommended missions. The overall program recommended by the decadal survey is simply not being adequately implemented. I would like to suggest 2 challenging and important actions. First, for both the Science Mission Directorate and the Earth Sciences Division, there should be a congressional plus-up above the President's request. Congress did this last year, and the result was particularly positive since it served not only to achieve the direct benefits one might expect, but it also encouraged industry to begin to invest anew in the technologies relevant to the missions recommended by the decadal survey. For the earth sciences, the target should be in a greater implementation of the missions recommended, as well as particular technology investments in the missions in the 2013 and 16 time frame. Finally, dealing with the reauthorization. We need to view NASA, and particularly Earth observations, in the overall federal structure. A key to making more efficient use of scarce budget resources is to develop a comprehensive approach to Earth observation from space. The Decadal Survey Committee expressed great concern that the nation's civilian space institutions, NASA, NOAA, and the USGS, are not adequately prepared to meet society's rapidly evolving Earth information needs. These institutions have responsibilities that are in many cases mismatched with their authorities and resources. Institutional mandates are inconsistent with agency charters. Budgets are not well matched to emerging needs, and shared responsibilities are supported inconsistently by the mechanisms of cooperation. It is important, I believe, that OSTP execute promptly the recommended study for a substantial overall comprehensive plan for Earth observation. I'm encouraged that they're doing this. I simply worry that the time is running out in this administration. Thank you very much.
Thank you, Dr. Moore. As you all have heard, there's a vote on. I think if we move with some dispatch, Dr. Squyres and Dr. Burns, we can get your testimony, and then the committee will stand in temporary recess, and then we'll return to direct questions of the panel. So, Dr. Squyres.
Thank you. Well, Mr. Chairman, Ranking Minority Member, and members of the subcommittee, thank you very much for the opportunity to appear today. In my opening remarks, I would just simply like to make 2 points. The first point is that this budget contains a lot of good news for solar system exploration. The budget includes a healthy increase in funding for research and analysis. R&A is important. It's where the nation reaps the benefits of the missions that NASA flies. It's where data get turned into scientific knowledge. So this is a very welcome development, and I applaud it. It's also good news that there's funding for 3 new robotic missions to the moon to be launched by 2014. This renewed emphasis on lunar science is consistent with NASA's focus on the moon as the primary target of the vision for space exploration. And perhaps the best news of all is that the budget also calls for the development of an outer planet's flagship mission for launch in 2016 or 2017. This mission would be sent to the Jupiter system, to Saturn's moon Titan, or to Jupiter's moon Europa. And any one of these missions would have enormous scientific potential. So there's a great deal here to be pleased about, and I commend Dr. Stern and the agency for what they've accomplished. But there's some bad news, too. And my second point is that I'm concerned about the dramatic cuts in the budget to NASA's very successful program of Mars exploration. In presentations to the science community, NASA has described a very exciting future program of Mars exploration. In 2013, an orbiter would be launched to study the upper atmosphere of Mars. In 2016, another major science mission would be launched, and then in 2018 or 2020, the long-awaited Mars sample return mission would be sent on its way. The reason that I'm concerned is that the budget doesn't appear to contain enough funds to carry out this program. Now, I say this based not just on my own intuition, but on a study that I participated in recently that was chartered by NASA and that was done in response to a request from the Office of Management and Budget. In order to fly the Mars sample return mission by 2018 and 2020, our study concluded that a few $100 million would have to be spent on technology development over the next 5 years. But as you noted in your opening remarks, Mr. Chairman, the actual number in the budget is only $68 million. So we concluded that either sample return would have to be slipped well beyond 2020, or that the missions in 2013 and 2016 would have to be eliminated. We are also concerned about the total cost of the Mars sample return mission. NASA's stated cost goal for MSR is $3.5 billion. That's less than twice the probable cost of the Mars Science Laboratory for a mission that's much more than twice as complex. And so we concluded that it's likely that the full cost of Mars sample return will exceed $3.5 billion by an amount that's comparable to an entire flagship mission. And that shortfall would have to be covered by a foreign partner. So there are problems. There are serious problems in the Mars program. Now, let me state very clearly and emphatically that the right answer, in my opinion, is not to move money from other parts of the space science budget into the Mars program. Everything that I talked about, the increases to RNA, the lunar program, the Outer Planets flagship, and everything you've heard from the other witnesses is a welcome development in this budget. I applaud all of that. Instead, my strongest advice to this committee would be that you strive to add to NASA's space science budget the funds that are needed to restore the Mars exploration program to the levels that were specified in the FY08 Congressional Appropriations Act. This would enable NASA to continue a program that has been a great scientific success and has captured the imagination of the American public. Again, I really want to stress that most of the news in this budget is good for solar system exploration. And if you can fix the one serious problem, the cuts to the Mars program, you can make this a space science budget that the nation can really be proud of. Thank you.
Thank you, Dr. Squyres. Dr. Burns.
Chairman Udall, Ranking Minority Member Feeney, and members of the subcommittee, thank you for your invitation to discuss NASA's astrophysics program here today. This is an invigorating time for astrophysics. In the next 2 years, NASA will launch several much-anticipated missions, including the Gamma Ray Observatory GLASS and the planet-finding telescope Kepler. And next August, the astronauts aboard the Space Shuttle will extend and enhance the scientific life of the Hubble Space Telescope. The astronomy community very much appreciates the continuing efforts of this Congress to fund these important programs. Mr. Chairman, in response to your first question about the direction of the astrophysics program at NASA, let me say that Dr. Stern and his staff have addressed many of the concerns regarding the previous astrophysics budget that was in place before they joined the agency last April. Included in the positive changes, a few of which we've already heard about, is the fact that the previous cuts in research and analysis RNA budget have been largely reversed. The astrophysics RNA budget is proposed to increase by 8.5% in 2009 and 48% in the next 5 years. The RNA program permits researchers and their students to mine NASA's investments in the astrophysics missions. Second, NASA has begun, as you said, Mr. Chairman, a new START, the Joint Dark Energy Mission, JDEM, in partnership with the DOE. Thirdly, NASA has opened competition for 3 new Explorer missions, and it is reinvesting in sounding rockets and balloon experiments, thus helping to restore the much-needed balance within the portfolio of science launches, particularly with the smaller missions. In all of these areas, NASA astrophysics is moving in the right direction. However, like my colleagues on this panel, I too am concerned about the overall drop, particularly for astrophysics. Using NASA's New START inflation index, the astrophysics budget is forecast to fall by $423 million, or 31% for 2013 in real buying power over that for 2008. This decrease is proposed to occur right during an era of significant new astrophysics discoveries that will commence particularly with the James Webb Space Telescope at the end of this 5-year period. The fundamental issue is that NASA is underfunded for its overall mission, which in turn creates budgetary stress throughout the agency, as noted once again by my colleagues on the panel. In my view, this is the key challenge that must be addressed by the Congress and the next administration. The astrophysics community will soon begin its decadal survey. Our task will be to set priorities over an ever-broadening scientific landscape. The proposed new missions must be realistically life cycle costed and cost capped based upon the best available models and experience. I believe that all missions, even those ranked by previous decadal surveys, must be evaluated and re-ranked according to, along with the new ideas that emerge. As we begin the next decadal survey, we're facing a daunting challenge once again due to NASA's astrophysics budget. How do we start, Mr. Chairman, new missions, as will surely be recommended by the decadal survey, with a budget that is forecast to decline by 31% in real buying power over the next 5 years? Regarding the large missions with budgets over $500 million, NASA is following the AAAC, the decadal survey, and other Academy committee recommendations. A few issues, though, are worthy of note. There is continuing concern about the potential cost growth in the James Webb Space Telescope, although I emphasize I have not heard of any additional imminent problems in completing and delivering the telescope to its orbit in 2013, but we must remain vigilant. For JDEM, NASA must now select a single concept for the mission and cap the total budget at $600 to $800 million so as not to impose further stress on the astrophysics budget. And thirdly, one of the possibly most exciting potential missions for the next decade will be the search for extrasolar planets. There are a number of promising concepts under development, but all must be vetted by the decadal survey. The community-based priority setting must be allowed to proceed, Mr. Chairman, without intervention if we are to select the best concept and maintain the budgetary balance within the astrophysics program. Finally, Mr. Chairman, you asked my views about reauthorization of NASA. From its founding days, NASA's mission has been exploration, human and robotic, scientific and technological, near Earth and larger cosmos. I recommend that the Congress reauthorize NASA to execute this mission on behalf of and for the benefit of our nation of explorers. Furthermore, NASA should be reauthorized with a budget that reflects this bold mission and its value to the nation. NASA must continue to explore in the broadest sense. Scientific exploration is equally fulfilling and synergistic with human exploration. NASA must continue to explore in a balanced fashion, recognizing that all facets of explorations define the benefit of the agency to the nation. Thank you, Mr. Chairman.
Thank you, Dr. Burns. The committee will stand in temporary recess for approximately 20 to 25 minutes. We'll return and ask the panel questions. Okay. All right. Hearing will come to order. I want to thank the panel for your forbearance. The chair now recognizes himself for 5 minutes. Dr. Stern, I'd like to turn to you, and I have a number of comments here that will be interspersed with some questions, so bear with me. This is, I think, the focus of our hearing today. The 09 budget request for NASA states that 8 projects have exceeded congressional thresholds on cost or schedule growth. This is an increase of 5 missions over the project listed in the 08 budget request. The 8 projects include Herschel, Kepler, the NPOS Preparatory Project, Glory, Orbiting Carbon Observatory Aquarius, Gamma Ray Large Area Space Telescope, and the Stratospheric Observatory for Infrared Astronomy. Given that the 09 budget request includes several new initiatives estimated to cost $500 million or more, what specific steps is NASA taking to address the problems with the 8 missions cited in the budget book and to ensure that any new initiatives do not exceed congressional thresholds? What, if any, margin is there in your budget request to handle any additional schedule and cost growth? I have an additional concern that I'd like to raise on this topic, and that centers on NASA's lack of responsiveness to Congress in complying with a statute that established the cost and schedule thresholds. Specifically, PL 109-155, the NASA Authorization Act, is clear in stating how quickly notification of such threshold breaches is to be conveyed to the Congress. In particular, the person overseeing the program experiencing such increases or delays must notify the administrator immediately and formalize such notification in writing no later than 30 days after the initial notification. In turn, not later than 15 days after receiving this written notification, the administration must transmit the notification received to NASA's authorization committees. Congressional committees receive copies of the program notifications for projects such as Glory some 4 months late. Considering the explicit timelines in the legislation, what caused such a lengthy delay? Furthermore, the Act requires that not later than 30 days after receiving the program's written notification, the administrator must determine if the program is likely to exceed development costs by 15% or more, or whether a milestone is likely to be delayed by 6 months or more. If the determination is affirmative, not later than 15 days after making the determination, the administrator must transmit to NASA's authorization committees a report including a description of the increase in cost or delay in schedule and action taken or proposed to be taken. We still have not received your report. The Assistant Administrator for Legislative and Intergovernmental Affairs notified the congressional committees that the mandated report would be submitted no later than March 2008. Even that would make it almost 6 months late. What is the reason for this significant delay? I'm concerned that NASA is not taking these reporting requirements seriously, and I will be pursuing this issue further in the coming months. Thank you for listening to such a long question, and now the floor is yours to answer.
Yes, sir. Chairman Udall, let me begin with your last point, and I'll apologize for the agency and offer to take that response for the record because I think it requires a detailed and careful response. And I understand your frustration, and sir, I can make a commitment to you that we will work to do this better going forward. I'd like to spend my time, if I may, speaking to your first two questions.
Please do, Dr. Stern. Thank you for that assurance.
Yes, sir. You asked about what management tools we're putting in place and what kinds of cost reserve postures we're taking, and that's what I want to respond to. Regarding management tools, there's a whole variety of things that over the last year we have put in place. I know you may have heard about some of these. I'm going to lay them out, and when you see them as a larger picture, I think you'll appreciate that we're really in a pretty strong posture now to go forward. We are oftentimes now lying in a bed made for us, that is, projects that were selected that had too much content for the available budget or too little reserves for them. SMD has now adopted a philosophy that doesn't try to stuff 6 or 8 pounds in that 5-pound bag. The missions that we're selecting, and I can tell you that all 3 that we selected last year, Beryl, New Star, and Grail, all came in well below their cost caps, and that they were verified by independent cost estimates made by non-advocate parties. And we looked at those very carefully and factored those into our selection criteria. So we're trying to make sure that missions have a lot of headroom. The administrator has required, from a reservist posture, that all missions above a threshold are required to have a statistical cost confidence level of 70%, which often requires reserves in excess of 30%, which are quite large by historical standards, something that NASA had not done in the past, for which Administrator Griffin should receive credit for insisting upon adequate reserves. We ourselves in SMD have taken D-scope seriously. I think you've seen examples of that on the MSL mission. You've seen some D-scopes in some Earth science missions. They're not always hardware or instruments. Sometimes they're done in the operations phase. They're done in terms of the testing or the degree of scientific analysis. We're actually trying to put feedback loops in place. In the same vein, we have on at least one occasion told a science principal investigator that if he can't control his costs, we're going to find another principal investigator for the mission. And as you're aware, We've also come forward with new missions that have cost caps, which is quite unorthodox. We're turning that from a rare to a routine practice. I think that those and other tools that we're putting in place, like PI minimum experience requirements, are giving us the suite of dials on the control panel, if you will, to ensure that we can manage the projects that we're starting to stay in budget so that overruns become rare instead of routine.
Thank you for that thoughtful and comprehensive answer, and the chair now recognizes the ranking member, Mr. Feeney, for 5 minutes.
Thank you, Mr. Chairman. Speaking of reports, I asked Mike Griffin, other than more money, which we all agree we would like to see for NASA, what 2 things he'd like to have. And first thing he said, well, I've got 53 reports annually due to Congress. I'd like to have a few fewer reports. But he also mentioned ITAR as a very important priority legislatively this year. Some things in the program can go on with or without congressional action this year. Does anybody have some comments on the importance of passing ITAR? Obviously, we have implications for the human spaceflight program, but are specifically with respect to the science programs, are there implications and importances in visiting ITAR as we deal with this that you could give us advice on as we try to take this up? Dr. Burns.
Yes, Congressman Feeney, happy to address that. We've wrestled with that a good deal at the University of Colorado in building missions, and particularly involving international graduate students and restrictions associated with them being involved, as well as we have a number of collaborations with England, Australia, Canada, and those restrictions to very friendly countries, countries where we have a number of graduate students and collaborators, have been very restrictive. Looking more broadly, though, I think the issue is one in which, as Dr. Stern said a little bit ago, we need to be looking at more international collaborations, because sharing the costs and the risks associated with these large projects in astrophysics, for example, the LISA mission, or the Constellation X mission, we need those international collaborations. The ITAR restrictions are making it more difficult than they need to be, and I think are really raising the risk factor for some of our missions.
Dr. Squyres, did you have something?
Yeah, I would just say that ITAR is some very well-intentioned legislation that has had some unintended consequences for space science in the United States that has actually worked against the best interests of the nation. As the principal investigator for the Mars Exploration Rover project, I've had the opportunity at Cornell University to have many very talented students come and want to work on the mission. These are students and postdocs from nations like Denmark and Canada. And we've had to turn away people because of the restrictions on ITAR. And these are people who could materially advance a United States space mission and make it a better mission. And if there's anything that this committee or that this Congress could do to reduce the burden in a way that in no way endangers national interest, and obviously that has to be foremost. But in a mission like operating rovers on Mars, I feel that we could involve international partners in a fashion that would put no national interest at risk and would benefit this nation.
Thank you. By the way, thanks to Chairman Gordon's permission, I expect to attend in Beijing the first Global Space Summit, the 3rd or 4th week of April. It's awfully presumptuous, but not surprising given the way the Chinese have advanced in their space programs, for them to be hosting the first ever Global Space Summit. But if we're not going to deal with international partners, clearly the Chinese are going to use it to every advantage, as well as some others. Dr. Stern, lately we've been hearing that NASA and the science community have used the word balance to describe managing goals, obviously with the budget constraints that we've all voiced problems with. Also, the allocation of resources across the agency, across specific science mission directorate, and across individual programs. Could you describe NASA's approach to the term balance and what meaning you give it as you evaluate the priorities in a resource-challenged environment?
Yes, sir, Mr. Feeney. Balance really comes in several dimensions, and it's important to recognize that it's not just a balance between the different scientific disciplines, earth science, astrophysics, heliophysics, and planetary science, but it's also balance within each discipline. We try to optimize for each field using its decadal survey as our primary guide, not optimizing for each individual program, because then we can't get to balance without averaging over the fields. It's also important that we balance in terms of the mission side of the house versus the research side of the house. Because if all we do is fly missions and collect ones and zeros and don't spend the money to turn those into discoveries that change the textbooks, then that's another kind of imbalance. And still there's one more that I'd like to speak to, and that's the scale of missions. We got a little bit out of balance in recent years with too many large missions compared to the number of small intermediate scale missions, as I said earlier. That stunts progress, and it slows innovation. We were certainly not in as bad a situation as space science reached in the early and mid-1980s, but it looked like we were slipping back towards that. We've made positive changes on all of these fronts with regard to the balance between programs in our new budget, for example, the Earth Science Initiative, with regard to higher RNA budgets so that we rebalance between the mission side and the analysis side. Within the individual programs, primary example being in the planetary program, where we were lagging in most of the areas, and we rebalanced using our best judgment and the decadal survey with regard to the Mars program. And we've made progress within the mission scales as well. When you look at our new starts, you'll see, and in the Explorer program as well, that we have quite a bit more small and medium scale missions than large scale missions.
The chair recognizes the inimitable, the one and only, the creative member from California, Mr. Rohrabacher.
Thank you.
For 5 minutes.
For 5 minutes, all right. And that's it. I was in a discussion earlier today about Arecibo and the tracking of near-Earth objects, and the fact that without we will not be able to actually track the trajectory of newly observed near-Earth objects, so that we will not know if some newly observed near-Earth object is actually going to hit the planet and kill millions of people. We won't know that without Arecibo, and there just seems to be this battle going on about whether or not that's worth funding. And it's a $5 million expenditure, and they're already laying people off at Arecibo. Now, I'm listening to all of these other things, and I'm wondering why that's more important than being able to protect the lives of millions of people should a near-Earth object, which we know appear every now and then. How is it what you're doing is more important than that?
So perhaps I'll speak for the agency, and others may wish to speak as well. We, as you know and as you've encouraged, we have an active program to detect near-Earth objects, to plot their orbits, to determine when they're potentially hazardous.
Okay. And with Arecibo, how will that?
Sir,
progress?
With the detection techniques that we use are optical; they're not radar.
Yes.
And in fact, most of the orbit determination work is done without radar. It's rare that even with Arecibo, that a small near-Earth asteroid comes close enough to be detected by radar. And that has to do with the technical nature of radar.
So my description of that the Arecibo telescope is a necessary component to determine the trajectory of near-Earth objects is not an accurate description.
Sir, I think those facts are you've got it right, exactly right.
Okay.
In fact, we do that by optical techniques. When an object does come very close, we can take advantage of radar to improve the orbits, but it's extremely fortuitous, extremely rare that an object comes sufficiently close.
I'm not saying that. I'm saying, is Arecibo significant? Is that what is necessary for us to realizing that near-Earth objects that come close to the Earth are rare, but also realizing that a rare object can kill millions of people, if not even create worse problems? Is the Arecibo telescope not vital to the mission of tracking that, or can you track it with just optics? Are you telling me you can just track the trajectory with just the
Yes,
optics?
sir. Arecibo is a nice to have, but it is not required, and it alone, for example, would not be able to track most
Right,
near-Earth
okay.
asteroids.
So I've been given the wrong information. Arecibo is not necessary. And are you all in concurrence with that? Arecibo is not necessary for the tracking of, to getting the right trajectory, so we know if an object is going to hit the Earth or not? Yes, sir?
Sir, I would say that the techniques of radar and optical are complementary to one another. Each has strengths, each has weaknesses. I believe that if we had the Arecibo capability, it would strengthen our capabilities in this area. It's difficult to use words like essential or not useful at all. There's a gray zone in between. Arecibo could make a significant contribution. There are many of us in the planetary science
Could it
community.
make, let me ask you this, make it a little more thing. Would it make you say a significant contribution, and it makes a difference, but it's, is it possible that you could have a near-Earth object that we find that is traced with our optics, and that without Arecibo that we could make a mistake, and that it would actually be something that could possibly hit the Earth, where otherwise with the Arecibo we would be able to know that it was going to hit the Earth? Is it,
Well, speaking as a scientist, I don't think it'd be responsible for me to say it's impossible, but I think it would be extremely unlikely. Keep in mind...
Well, it's also, by the way, it's also extremely unlikely that anything will ever hit the Earth, period. We know that in our lifetime. But given something that's up there, how unlikely, you say it would only help us 10% more? Or is
I can't assign a number for it. I'd be happy to take that
Okay.
for the record and do an analysis, but I will tell you that we have other radar tools in our inventory
Okay.
that are NASA assets. Arecibo, I remind you, is an NSF asset, and NSF chose not to fund it. It's not a NASA asset.
Yeah, no, what I've got
We are
back from
funding our
NASA,
radar
and
assets.
NSF and NASA are both fighting who's going to get $5 million more in their budget, and the other guy has to have. This is all, as far as I'm concerned, it's all bureaucratic budgeting and game playing with turf just to save $5 million in their budget. But this is the first time that I have, Mr. Chairman, this is the first time I've asked this question in which I've received the answer that Arecibo is not an essential element to tracking near-Earth objects. So I'm glad you're on the record now, because we'll look into that. And frankly, this is the first time, and I take it that everybody concurs with that, except you have a little bit of a disagreement.
Can I at least decide whether I'm going to concur or not here for a moment?
Please,
But
I asked.
I just remind you that
Yes.
that in the last years, I believe it was in the Appropriations Act, there was a congressionally requested study of the National Academy on this issue, that is to assess, including the role of Arecibo in this problem, and the Academy is currently forming a committee as requested with NASA sponsorship to give you that kind of an answer on all aspects of this thing, and I think I think that will provide you with all the information that you need.
That's very good. And when is that due?
Oh, help me out, Harsha. Late 2009. That's an Academy study.
Well, by then, Arecibo will be closed up, and that doesn't sound like it's going to help us at all. Mr. Chairman, we've got some decisions to make, and I'm going to be looking directly, and I thank you for that. You're the first person, we've been discussing this for 2 years, and you're the first person who stepped forward and said, no, Arecibo isn't really that essential. So thank you.
I thank the gentleman from California for his passion and for his interest in this, and as he and I have discussed, we are on, and as the ranking member also has been involved, we are on track to reauthorize NASA in the next couple of months, hopefully. I guess it's the next 3 or 4 months, but this will certainly be a part of the discussions that we have as we move towards a reauthorization act. So I would thank the gentleman. And the chair will now recognize himself for an additional 5 minutes. We'll have another round if that's acceptable. Dr. Stern, let me move back to the budget request again, and particularly the reduction of the programmatic content in the Mars portion of the budget by $918 million from FY09 to FY12. And at the same time, the proposal includes a maintenance of the sequence of planned Mars missions and adding an ambitious Mars sample return mission for launch in 2018, which you heard about earlier. Various expert groups chartered or convened by NASA have analyzed the budget plan and have expressed their views that the FY09 budget and assumed budgets beyond FY13 will not support the Mars program that NASA has outlined. let me ask you about some specific areas of concern with respect to the proposed Mars sample return mission. I understand that it's typically is good program management practice to spend some 4 to 6% of the overall mission cost on developing required new technologies for a mission before actually embarking on the project. For a Mars sample return mission, that's expected to cost in the order of $5 billion. 4 to 6% would suggest that several hundreds of millions of dollars is needed for early technology risk reduction. Can you tell me how you arrived at the low figure of only $68 million over the next 5 years for the Mars sample return technology risk reduction? Can you cite any other successful NASA science missions that spent such a low percentage on technology risk reduction without incurring cost growth and schedule delays? Next, serious concerns have been expressed that both the funding profile and the total budget for NASA's Mars sample return mission are unrealistic, and that an attempt to proceed with MSR as envisaged will lead to the need to cancel other Mars missions and ultimately to slip the schedule and increase the cost estimate for MSR. How do you respond? And then Dr. Squyres will put you in the queue and like you to respond to Dr. Stern's comments when he's finished. So we'll start with Dr. Stern.
Okay, thank you, Mr. Chairman. That's a hefty topic. I need to take a few minutes to lay out that full picture for you because the topic is deserving of it. We have an exciting Mars program, and I want to deconstruct for just a moment the claim that our Mars program is not executable. When you actually ask the Mars experts, and I hope Dr. Squyres will weigh in on this, and you say, well, we have the Mars Science Lab, the Aeronomy mission that Dr. Squyres spoke of, a to-be-named mission in 2016, and then Mars sample return. Which of those do you have a problem with when you say the program as a whole is not executable? And when pressed, the Mars Science Lab is generally deemed by experts to be executable. I think people believe that we can do the Aeronomy mission on the roughly $500 million budget set aside for it. It's really not possible to say that the 2016 mission is not doable on the $880 million budget set aside because the mission has not yet been scoped. We've asked the science community to tell us what they want to do in that budget. And until they come back to us, then there's nothing to argue about. We're looking for that guidance. Now, with regard to your specific question about MSR, keep in mind that it was only in May of last year, as we were formulating the budget, that I elected that we actually take a stand, put a stake in the ground, and use Mars sample return as the central organizing theme for our Mars program going forward. Now, every Mars report of late, the Joukowsky report of the National Academy last summer on astrobiology, the MEPAG reports in our advisory panels, etc., put Mars sample return at the top. We're now putting it at the top of our priorities. We can't execute that mission until approximately 2020 because our European partners who are interested in collaborating at about 40% of the total cost have commitments of their own and cannot themselves ramp their budget until the middle of the next decade. So while we're executing MSL, the Aeronomy mission, and the 2016, we cannot be building up the MSR budget because we would be ahead of our partners and the phasing wouldn't work. Now, we put $68 million in this budget, and the purpose of the $68 million is not to do all of the technology development for MSR. To the contrary, this is our money for doing the architectural studies that we'll be doing the next couple of years to determine exactly what MSR consists of and which technologies need to be developed, as well as some early lead technologies that we're making an initial commitment to. Now, it's up to the Mars community. We've told them, if you want a smaller mission in 2016 and a steeper ramp to MSR, that $880 million is out there, and it can be used for both purposes. And so we can address just the 5% sort of number for technology development, for advanced development for MSR, if the community comes back with a mission that's properly scoped for 2016. If, on the other hand, the community asks to use the entire $880 million for science mission in 2016, then MSR is necessarily going to have to wait on its technology development to a later date. But that's a decision for the scientific community to make.
Dr. Squyres, would you care to respond and provide your perspective? And I would ask the committee's indulgence. I think this is an important enough question that we'll go over my time a bit and make sure we get for the record your point of view.
Yes, sir, I'd be glad to. I agree wholeheartedly with Dr. Stern that a Mars program that consisted of the Aeronomy mission in 2013 for a cost of $550 million, I believe it is, another Mars mission in 2016 at $880 million, which is a hefty sum, followed briskly by Mars sample return, would be an exciting program. And I think you would find that many of us in the Mars community, certainly speaking for myself, I would stand solidly behind such a program. As Dr. Stern pointed out, and I agree, the money that's in the President's budget request for FY09 fully supports that 13 mission and that 16 mission, and we can do great things with those two missions. The problem, simply stated, is that the $68 million that is available in the next 5 years to do studies in preparation for Mars sample return is not adequate in that time frame to support, in the judgment of myself and many members of the community who have looked at this very hard, a sample return mission in the 2018 and 2020 timeframe. So a consequence of the budget as it has been submitted is there are two possible outcomes. It's really very simple. One possible outcome is that we do the 13 mission, we do the 16 mission, we do great science, and Mars sample return simply moves downstream. And I don't think what I just said was too much at odds with what Dr. Stern just said. The other possibility is if you choose to anchor in 2018 and 2020, the sample return mission, then the money that you need to spend to get ready for those missions in that time frame, which you correctly state is in the realm of hundreds of millions of dollars, has to be taken out of the Mars program, and that means that you're not going to be able to do the 2013, 2016 missions. So I think it's an either-or proposition if we are faced with the very large cuts to the Mars program that the current budget entails. If, however, the money that were provided for Mars exploration was put back to the levels that we have enjoyed over the last several years, I believe that it would be possible to carry out in full the program that many of us in the community would like to see, and that Dr. Stern I'm sure, would like to see as well. And that would be the 13 mission, the 16 mission, and in that same time frame, do the advanced technology development necessary so that you could actually do sample return, which remains a very high priority for the Mars community in 2018 and 2020. I hope that's addressed your question.
Thank you, Dr. Squyres, and I might, before I recognize the Ranking Member, Mr. Feeney, tell the audience and tell the rest of the committee that when we end the hearing, and I think we'll have another round depending on people's time schedules, you're going to finish the hearing with some recent images from the Mars rovers. And,
I would enjoy doing that.
I know I'm very much looking forward to that. I want just everybody to know here that stay, because the end of this will end with a bang here today. So the show recognizes Mr. Feeney for 5 minutes.
So our technical budget questions are standing in between the audience and exciting video slides. Okay. Well, I'll try to make my questions penetrating then. The NPO ESS program has had significant problems over time, budgetary and meeting its goals. That led to the Nunn-McCurdy review. And ultimately, that meant that a number of climate sensors were dropped from the satellite in order to limit cost growth. The program was also rebaselined at that point. Is NPO ESS meeting its revised schedule and its cost milestones? And what are the largest threats and challenges we have? Dr. Stern, why don't we start with you, and then anybody else that wants to weigh in on that?
Yes, sir, very briefly. After the restructuring, the mission has been doing much better. It's a very ambitious undertaking, and simply put, we have a long way to go. It's still early days in the development of both the payload and the spacecraft. So while I think it's doing considerably better, we have to be ever vigilant.
Is anybody else, Dr. Moore? Yeah, please.
I think the program has had many problems, and one of the problems has been a technology hurdle associated with the imager, referred to as VIIRS. It appears that those problems are not yet behind us, and that perhaps for some of the geophysical variables like ocean color, we're not going to be able to achieve the requirement. I think the the question that really stands before us is that each time we believe we have the instrument, shall we say, we're over the worst hurdles, a new hurdle appears. And so I think it's just the concern with the past performance that we've constantly stumbled, even though we thought we were near the end on this particular instrument. I agree with Alan that I think that we are beginning to see, and not to use an old phrase, the light at the end of the tunnel, but and hopefully it's not the train coming towards us.
Well, and when we're talking about lights at the end of tunnels and we're looking into space, those are light years away sometimes. We don't know how long those tunnels are finite here on the planet. But Dr. Fisk, you raised the issue that's a concern to a lot of us on a lot of fronts in NASA, and that's the workforce issues. It's something I think all of us are focused on. It's not necessarily a specific budgetary issue, but you were the one that raised it in your talk. And I was interested, given again the parameters we have with the likely budget outcome, if you think that there are things we can do differently to excite future science and math scholars through our science program, or for that matter through the spaceflight program, if you think that there are different things that NASA can be doing, because it serves a twofold purpose in my view. Number one, we get kids focused on the subjects that they need to master for us to be a preeminent space society, and that's math and science, which also has a lot of import in other areas for our economy and strategic and military capabilities. But it also conceivably would help generate the sort of support that we're all looking for in the public for NASA's mission. So maybe we can get the $800 million to advance the Mars program, and maybe we can shorten the gap in the human flight. So it's a dual purpose if we can find a way to do it. NASA does, by the way, of all the agencies, they get more hits from school websites, they get more interest from teachers in the science field. So Dr. Fisk, why don't you start, and if anybody else has any thought about what we can do within existing parameters to get that excitement started.
I think I've always thought of this problem in sort of two different ways. There is the question of encouraging people to go into science and math in general, engineering sciences as well. And there, just simply the excitement of space and making that available to the school system is obviously an extremely positive thing and encourages people to go into the fields. But it isn't the problem. There's a separate problem, which was once you've encouraged them to go into math and science in general, do they want to go into space? And that's a second problem because that problem comes up at the university level. You've encouraged people to go off and get training in engineering degrees, undergraduate degrees, and so on. And then they have a whole series of options available to them, which are in the best interest of the nation, whether they're, nanotechnology, various kinds of sensor technologies, any number of things. Then the question is, should they go and will the best and the brightest and go into the space business? That problem is actually not that difficult to solve, in my judgment, because what happens is, I think all our experiences, Jack Burns at the end, who, and all of us and Steve that are in universities have discovered that when you engage students as undergraduates in technical fields in participating in some aspect of space, research projects, hands-on experience, and so forth, they inevitably want to go into the space business. And they're encouraged to do so. They feel they see the excitement firsthand. And the converse is also true. When you don't, the lures of all the other disciplines. So the nation can decide if we need people in these fields. We have so many challenging activities coming up in space. We have challenging activities and our workforce is starting to get old in the space business, and as a result, we need to vet these people in. They need to be the best the nation can offer, and there's a very simple process that you can do that, engaging the universities, because by this point they've decided to go into the field. That happened earlier. Now the question is the yield factor for space. Thank you.
To turn the problems slightly differently, I think in your discussions that we had earlier about ITAR, this is an area where not only for the university community, but for the NASA centers, a fresh vision would be very helpful. I know that it's a burdensome aspect for JPL as well as for Goddard and other NASA centers. There are certain very real reasons for ITAR, but I think that they could be scaled back, and that would directly address what you've raised.
I just wanted to comment that I think that a lot of what we do in the space science program has enormous potential to inspire young students to go into careers in math and science, not just in space, but in math and science overall. And I think we need to work very hard to find creative ways to engage those students in ways that are going to be captivating for them. I recently had a fascinating experience. I gave a talk to 20,000 young middle school and high school students, mostly from underprivileged school districts in Detroit. I did it at Ford Field where the Detroit Lions played. I was lined up on the 10-yard line between the hash marks with the end zone filled with middle school students and showing pictures that had come down from Mars 4 hours before on the Jumbotron screen. They were captivated. They get turned on by this. And if we can take what we do and the passion that we all feel for what we do in space and we can find creative ways to reach those people, it's an enormous resource out there. It really is.
I agree very much with my colleagues on this topic, but let me add one other nuance here and an issue that we face, and that is that the timetables today are getting to be so long for these space missions, a decade or more, that it's difficult to attract students into these programs because the timetable for building these instruments is well beyond the typical tenure of a student either at undergraduate or graduate level. And so they don't have a chance to fly these missions, if you will, while they're in school. So we have a problem that it's making it difficult to attract new instrumentalists who will build the next generation of spacecraft, sensors, or imagers. And it's something that we need to face. I think Dr. Stern is helping by re-implementing. We almost drove the balloon and the rocket program out of existence. And so this is very helpful in that regard, but we really need to do much more.
Thank the panel for some really important insights into this crucial area of how do we recruit young people into these important fields, and then how do we retain them and give them a sense that this is very worthwhile. The chair recognizes again the gentleman from California for 5 minutes.
I would just note that unless our children have a good foundation in science and mathematics, that you're not going to be able to recruit them later on. And let me just note that all the hearings that I've had, especially yesterday with Gates, it's very clear that there is such a hesitation to confront the political problem of permitting science and mathematics teachers to receive more pay than the teachers of other subjects. And pay differential is the fundamental issue that's going to either make us successful in giving these fundamental skills or not, because you've got dozens of people who want to teach English literature and history, and they frankly don't, for every one person that you can maybe attract to teach science and mathematics. And the science and mathematics people can make a lot more money doing something else rather than teaching. So we need to pay them more money. And there was a movie called, and I remember they said it was about a baseball team. They said, "Build it and they will come." Well, pay more money and they will come. And unfortunately, there's a major political impasse in that certain political people have relied on unions and the educational unions, which would rather hold America back than give up the right to have every teacher in every subject has to be paid exactly the same amount of money. That's the fundamental problem we face there. I was also mentioned someone seeing the light at the end of the tunnel. I hope when they're looking through a telescope, the light at the end of the tunnel isn't a near-Earth object headed in our direction. And I think someday it will be. And I understand there's even been some near-Earth objects that have, they come so infrequently, but there happened to have been one just a short while ago that came between the Earth and the Moon. That close, we didn't even know it was there until after it had gone by. And I think that it's worth our while to be able to look out. And by the way, that's also something that we actually passed some legislation that gives awards to young people who, if they look into the skies and discover some near-Earth object, we give them an award. I think a Pete Conrad Award that I authored the bill that permits and gives this award every year to a young person that discovers some object. So that's a good way of getting young people involved as well. Let me ask, there was mention about earlier, and I believe it was you that was talking about the discovery of planets, outer planets or something that NASA's doing?
Congressman Rohrbacher, I think exoplanets, is that
Yes.
what you're referring to, around other star systems?
Yeah, how much are we spending discovering these extra planets?
Well, I have to I'd have to turn to Dr. Stern because I don't know those numbers off the top of my head, but we've got a new mission which is going to be launched next year called Kepler that is going to be dedicated to looking for new stars. Right now, based on ground-based observations, over 250 planets are known to now exist around other star systems.
The question that I need to answer here is, why are we willing to, this is obviously an expensive proposition, why are we willing to launch a new program that's going to cost money to find out about planets from distant stars when we're not willing to spend even more than $3 million a year trying to find near-Earth objects that may or may not hit the Earth and kill millions of people?
I think that's for me.
Yes.
Well, let me say that in executing our exoplanets program, we're following the recommendations of the National Academy. It's a very exciting program. We have a number of spacecraft that we're turning to that task, and we're building Kepler.
How much is that going to
Looking
cost?
forward to future programs.
How much will that cost?
Well, those missions are typically in the Kepler cost class, and they're $600–800 million.
Now, Mr. Chairman, let's just note, $600–800 million, and we're quibbling over whether or not we're going to really have a program that can really take care of charting all of the near-Earth objects in a very quick time, just to see if one of them might hit the Earth, and quibbling over a $5 million telescope, which may, and I'm going to look into this, which may or may not play an essential role. If it doesn't play an essential role, I'm going to take that back, and I'll call my friends at Cornell and tell them I got the wrong information last time we held a hearing. I do seem to remember, Mr. Chairman, last time we held a hearing, all of the witnesses told us how vital this telescope was, but to spend hundreds of millions of dollars to find a planet in distant stars and not be willing to, it just seems to
Mr. Rohrbacher, if I may, I'd like
Sure.
to tell you about our NEO program, because it's an exciting program as well.
How many? It's a $3 million program,
Well,
is it not?
it's commonly referred to as a $3 million program. In fact, because we were lagging in our goal that the Congress set to finish by the end of 2008,
Right.
detecting 90% of all the kilometer-class potentially hazardous objects near the Earth, I actually took some of my discretionary funds and helped that program along this year. So it's actually be funded at a little bit higher level than that. But I want to also point out that's not the only way that we study near-Earth asteroids. We have programs in fundamental research in our Planetary Science Division. We've flown a mission to orbit and then land on a near-Earth asteroid
I was there when they did, yes,
called
great.
NEAR. You're
Yeah,
probably
right.
familiar with that mission.
Sure,
I think its
terrific.
cost level was several $100 million. I think it's about $250 million. We have a mission on its way, although not to a near-Earth asteroid, to orbit two of the largest asteroids in the asteroid belt. We have a whole variety of programs that address the nature of asteroids, their composition, their structure. This all helps inform us about the near-Earth asteroid problem in one way or another, and we are doing the program that the Congress asked us to do, and I expect us to meet that goal by the end of 2008.
Very good answer. Thank you.
Thank
sir.
the gentleman from California. I want to recognize the gentleman from Florida for a comment.
Yes, I'll be brief, and then I know the chairman has some questions, but I'll be done for the day after this. I have a big interest in the near-Earth object issue as well. I'd note a couple things. Number one, some scientists believe 64 million years or so, again, dinosaurs and other entities went extinct around the planet because of a near-Earth object actually colliding. We actually had a big one, I think, in 1908 in Siberia that would have been catastrophic. So these things do occur, and I think that Congressman Rohrbacher's concerns are genuine. I would point out that I think, if I remember the testimony right, something like 99% of the resources spent on detecting near-Earth objects are American resources, it would seem to me like other spacefaring nations and scientific nations, this is one where it's not a zero-sum game. We're sort of all in it together. And I think this is one that begs for international cooperation. And then finally, I'd suggest, and I'm sorry Dana's not here to hear it, but sometimes we give these warnings and we get to later say, I told you so, but if it's going to be hard to hold anybody responsible if we get hit by one of these things, the human race goes extinct, it's just going to be tough to hold any agency specifically. So one of the problems he has is that there's maybe more immediate concerns from folks that have to allocate resources. With that, Mr. Chairman, we don't get to see slideshows in the Financial Services Committee, so I'm going to give up my questioning time and
I know the ranking member and I will do everything possible to hold a hearing if that day does arrive. Dr. Stern, if I might, I'm going to take a few more minutes and then we'll end with some inspirational images from Mars, from the red planet. And you may want to direct this to Dr. Freilich, I know who's here. What, if any, research are you doing in the Earth Science and Applications program to better understand the impact of aviation on climate and how it might be mitigated? Do you think NASA should be doing research in this area if it's not already, given the potential for regulatory actions to penalize aviation emissions down the road? And then, Dr. Moore, you may want to comment once the NASA team has had a chance to comment.
Yes, sir. Well, I think if you'd like a full answer on it now rather than taking it for the record, I would invite Dr. Freilich to the microphone, and he can give a better answer than I could, if that's acceptable. Please, Mike.
We will take it for the record and give you a complete answer. I can say that there are several aspects of aviation and applications and science that are covered in our programs. In the science programs, our fleet of satellites measure atmospheric compositions and measure cloud and aerosol properties. Some of these clouds and aerosols are the result of aviation exhaust, if you will, or whatever, the result of aviation. It's fairly prevalent. Actually, not surprisingly, but when there was little aircraft flights over the U.S. Right after the tragedy of 9/11, it gave us a remarkably clean view from our flying satellites of the situation without aircraft that could be compared to the normal situation with aircraft. And I will get you in more detail the specific studies that are going on right now. We are also in the applications program conducting a number of studies with the Federal Aviation Administration and NOAA to improve aviation and its interactions with the environment, in particular the effects of icing on aircraft and predictions of that, to better route aircraft and to improve the overall air traffic system.
Thank you, and Dr. Moore, please comment.
It seems clear to me that certainly in the Aeronautics program, looking at aircraft efficiency and in particular the issue of carbon emissions is going to be a great opportunity. In some of these, we ought to recognize that these green issues, well, the color of money is green. And in terms of being competitive, we should think about can we improve the U.S. aircraft fleet so that on carbon emissions, it has lower carbon emissions per traffic mile, per passenger mile. And that's going to be particularly important as we look to the era of cap and trade on carbon emissions or carbon tax. These will become very real economic benefits for the country if we could make the kind of engineering progress that I think is that would be natural for an aeronautics program to focus upon.
Those are excellent insights, and I agree with the right leadership, the right incentives, in some cases the right regulatory structure. I'm betting on our entrepreneurs, on our capital flows, on our technology, and it's one of the shortest but the most powerful sound bites around right now. There is green and green, so I appreciate you pointing that out to all of us. We want to sell this technology all over the world. Thanks again to the panel. Dr. Squyres, do you want to end with some inspirational, exciting
Yes, sir. I would enjoy that
images of
very
the
much. I
planet?
always like showing off the latest pictures from
Please,
Mars.
and if we can bring the lights down,
Yeah, that'd be great.
make it even more exciting.
Yeah, today is day 1,491 of our 90-day mission to Mars. Both Spirit and Opportunity rovers are continuing to do extraordinarily well, doing great science, and moreover, they are part of an armada of spacecraft from NASA, also a European spacecraft that are at Mars right now and daily sending back new data. I've just brought a few pictures for you. This is a recent picture from the rover Opportunity. Opportunity landed about 6 kilometers, about 4 miles to the north of where this picture was taken, over a period of years, drove to a spectacular impact crater called Victoria Crater. It's 800 meters in diameter. It's about 70 meters deep. It's a spectacular window into the subsurface of Mars. As we speak, Opportunity is down inside Victoria Crater, going down into the rocks, exploring, and sort of taking a trip back in time as we look at the rocks exposed there. One of the reasons that I chose this particular image is that if you look off in the distance, sort of on the far horizon, you'll see a large cliff there. That's about, 25, 30 feet high. That's a place that we've named Cape Verde. And after we finish doing the geology that we're doing at this particular location, we're going to try to get as close as we can to that and take what should be some absolutely stunning images of it. This picture came down from the Spirit rover less than 24 hours ago. So this was happening on Mars yesterday. Spirit is in a place called Home Plate and is investigating some rocks immediately in front of the rover. You can see the rover's arm reaching out and making measurements. This particular rock outcrop is one that we've named Wendell Pruitt. Wendell Pruitt was one of the members of the Tuskegee Airmen. We have chosen the Tuskegee Airmen to honor to name rocks in this particular area as one of the first great African-American fighter pilots. And here's a picture of Wendell Pruitt, the rock. This was taken with our microscopic imager just a day or so ago. I will not attempt to analyze that image. I just saw it for the first time yesterday, but stuff is happening on Mars. I also wanted to show you one more image, and this comes not from the rovers, but from one of that armada of orbital spacecraft. Every now and then, Mars will just surprise the heck out of us. And this was a wonderful one. What you are seeing here is an avalanche caught in the act of happening. This is a picture taken from a spacecraft called the Mars Reconnaissance Orbiter. It has a spectacular high-resolution camera that can look down from orbit and see objects as small as a meter or so in size. And this is near the Martian North Polar region on a very steep slope, and this is an avalanche roaring down a slope on Mars, and we happened to catch it as we were flying overhead. Just beautifully, to me, illustrates what a dynamic and interesting place Mars is. So we continue to do the best science that we can, and we appreciate your support.
Those are terrific pictures, Mr. Chairman. You know, to a Floridian, they look a lot like parts of Colorado.
Thanks again to the panel, Dr. Stern. Thank you, Dr. Fisk, Dr. Moore, Dr. Squyres, Dr. Burns. Another inspirational panel. Thank you for your commitment to this very, very important part of our future. Look forward to having you back, and thanks again for your time. Thank you.
Thank you.